everyone, we are Group 2 and we are doing the binding and foot region of the Mountainboard. And our group members are David, Adam, and me.
You don't know me, but
yeah. You helped out, he was great.
what's your name?
Alright.
So, this is our binding. That was the original SolidWorks model. We bought the strap and the buckle and all the material for the anti-skid padding for the base plate. We used a adjustable angle binding so that we can tighten the strap, and it should be low enough to suit people for any different foot size. We don't have any padding for cushioning right here, but the anti-skid material is close to what they use in a real skateboard. And we made the base plate from 1.45 millimeter stainless steel sheet metal thickness with the bending with the bending machine, and laid the anchor plate. So the base plate is made out of stainless steel. The anchor plate was made out of aluminum stock, which was the same stock that was left over from making the wheel design that Steven made. The base pad we made out of silicon and rubber using a mold that was rapid prototype based off of a SolidWorks part design. And as we said, the straps and buckle were purchased, as was the anti-skid tape.
Alright, for our design analysis, we wanted to get a base plate made out of stainless steel in order to withstand the product wear, and it was really tough and hard to break. I know that personally. And we had anti-slip bottoms, which turned out really good. We just taped them on there, and it ensured stability and made sure, hopefully we can still get the anchor to turn on it, and the anti-slip won't interfere in that. And we have a pad and adjustable straps, so it should be still comfortable and safe. So that's all pretty good. And our manufacturing methods. We rapid prototyped, well, Adam did, on SolidWorks, a mold, and we rapid prototyped that. We were working backwards from what we normally did in 216. We filled the cavity with rubber, and so when you pull that off, it should be the pad that goes on top of your foot.
It's the same silicon rubber material that we use to make the molding in 216 for our keychains.
So it's kind of working the opposite way. And our sheet metal, we just took the metal, we went over it with a marker, the outline of how the base plate should be, and we went to the notcher and had to cut that out and curve it. Then we took the Dremel and actually went around the curves and formed them more nicely and made it look better.
The notcher was that kind of machine that had two large metal plates that were formed at a right angle.
Yeah.
You pull a lever and it just shears straight through the sheet metal.
So it's good to make corners and straight lines, and you have to really do it several times to make curves. And today we actually got the anchor finally finished using the lathe machine. The only thing we have left to do about that is figure out a way to make it flatter, just so it doesn't stick out so much. You got something bulging near the center of your foot. And as the straps and bindings, we have them, we purchased those, so basically that's all our main pieces. We just have to assemble them. And just thought I'd throw that in there to look nice. That's the G-code we used to make a 3-inch circle. Right on.
Yeah, that was a G-code used for making the circular hole.
Yeah, it's actually big. The other group have pages of G-code. This is our pride and glory.
That hole is actually very difficult because sheet metal is evidently not well suited to being used on those milling machines at all.
We struggle a lot with this because this is harder than most of the tools usually to cut. So we're just like, we used a Dremel to go around this, and we got about 2 inches, and the actual grinding wheel just disappeared. So
yeah,
we went through a lot of those. We'll okay all that.
Yeah, we couldn't use G-code to make the periphery of the sheet metal because we could not hold that down tightly enough to make the edges and the ends. When we tried to make that circular hole, it wasn't tightened enough. There wasn't enough clamps on the actual base plate, and the whole thing just jumped and considerably damaged the $80 tool that was on the CNC machine.
Anyway.
One of our difficulties.
So as far as design scalability, we try to design the product to be as flexible as possible. We had adjustable fitted straps for comfort, depending on the use of the adjustable stand. You can angle the base plate on the floor whichever way you like. And piece by piece assembly, you can really take the whole binding assembly apart and just have each individual piece by itself, which is good if you see room for improvement in one piece. You want to affect the whole design, so you can go back and replace pieces later on if you see a chance for an upgrade. Difficulties, yeah, like Sam was saying, cutting the stainless steel, bending the steel to desired angles on the bending machine, and designing the mold cavity for the anchor on SolidWorks.
And a lot of us do it, but that happens to that was like clamping everything. We had to figure out ways to clamp them on all the machines. So that was pretty hard. Just getting the fixtures.
We had a lot of difficulty figuring out how to cut out the pieces for the base plate. It took all three of us to use a notcher to cut the sheet through the metal.
Yeah. There's a lot of shows to do that.
Future enhancement. So as far as looking towards for improvements, maybe an adjustable base plate length. So depending on the foot size, you could extend or lower the size of the base plate depending on the person's foot. Additional padding for the foot. Right now, the only pad is the one on the top. There's no padding on the side where the straps come down, so maybe additional padding there. And maybe Velcro straps, which would be easier than buckling and loosening the strap every time you're taking the shoe off. And in conclusion, we learned the importance of communication within the group, dividing out who's doing what and when they're supposed to do it. And outside of the group with other groups, we collaborated with the board group a lot as far as where holes would go in the board and in the base plate. The importance of teamwork, as we said before. Nobody in the group is greater than anybody else, so everybody had to pitch in and do their part. And as far as thank yous, we'd like to thank groups 1, 3, 4, 5, and our instructors.
Yeah. Well, we drove him crazy until we got the mold cavity finished. And,
yeah, we stayed in this office a lot. So.
Yeah, we kind of asked you a million questions.
I'd like to thank Dan for working overtime with me yesterday, not yelling at me too much with it, or stayed a couple hours overdue in the last few features yesterday.
And thank you all very much.